and I'm the CEO founder of WaterBit. Some people in the audience have already seen me and seen some of the things we're doing. There have been changes since the last time we spoke. So right now we're looking at a very focused company on an area of smarter irrigation. And so you will notice I don't use the word IoT very often. Our goal is to help improve irrigation in a way that's very deterministic. Today it is not in the world of agri-tech. So today we have been looking, we've spent several months and weeks in the field. I've got a new pair of tires out of that. And most of the time has been on 99, 5, and 101. What we identified was that every grower in the business wants to be more responsible and use less resources. But in order to control anything, you have to be able to measure it. And you have to measure it consistently, reliably, accurately. What we found is that the costs of doing so are incredibly annoying. And they're based on fundamental technologies that do not work. Capacitance, TDR, resistance-based things are currently what is in the market. On the top left-hand side is a product from Australia that has its total vertical stack value by the time you install it over 3 years. Cost of ownership is between $8,000 to $10,000. It's not scalable. So if you want to apply data science, you actually have to have data. And it might sound very novel, but if you think about having a sensor point in a farm that costs $10,000, that is meaningless. So what we did is we went back to physics and we invented a new sensor that used magnetics instead of all the other things. With that, we were able to reduce the cost at the entry point in our technology to less than 1/10 the cost of competing systems. And we had the start of our technology curve. All of us can see this display on the left-hand side and you know where that cost line is going to go. In addition to dropping the cost, we also improved the performance, the sensing radius. So the volume of soil being sensed is tremendously different. If you look at the cute little picture we have, the intent is if you put one of these sensors between two vines, you actually get a measure of how much moisture is actually in the soil. So this is a very cute little soil moisture system. It's also patent pending. This would show a video, but I'm fairly sure it will not, so I recommend you to go to our website because I think we don't have QuickTime installed. If you do, you'll notice that this sensor can work through an air gap and still pack up moisture in potting soil, Miracle-Gro. I believe somebody referred to Miracle-Gro earlier. We have the only sensor that actually works in the loose texture of potting soil, which has interesting implications for market expansion later. Our solution over here is built on basically installing a probe with a long-range wireless connection into a cloud that currently runs on Google and then downstream into our software application. So that provides a complete sense, communicate, and decision loop. Driving, right now we have targeted the majority of almond growers. At this point in time, the almond growers we are working with represent about 5% of the global almond production. You can derive a lot of economic insight from that. And so the opportunity we have, this is a single point where we use the word IoT to fit in with the audience, is that we are selling our product as a service. It's a subscription model, $300 a year, for the high-end version going down to $150 a year. That is less than 1/10 the cost of any other competitor in this space. Remember that it's not a consumer product. This is our first proof of concepts. We did a science test. This was UC Davis last year. On the left-hand side is one of the researchers from Davis. Right-hand side is Kevin Yamada, a mechanical engineer. And you can see the contraptions needed to install other people's products. We have been breaking up our problem into sensing and wireless communication. This is a radio installation that we were trying in Madeira, hooked up to a pressure sensor. And you can see the performance we're getting is about 3.5 miles. How many of you have actually been on a large-scale farm in Silicon Valley? 1, 2. Great, thank you very much. So with this, you probably know that getting a wireless system to work reliably at more than 500 yards is an achievement. Thank you. So anyone who tells you they use Wi-Fi in agriculture, pass. It just won't work, right? Microwaves, water. So where are we today? We are poised for launch. We've started generating revenue. Right now we're averaging about 10K per month. Obviously we're very early. And one of the challenges that comes with that is we started generating revenue ahead of our product being ready. So right now we're working on the products. We shipped purchase orders for our build yesterday. And we have a number of beta sites. We have 6 branches, 2 major corporations, one in Japan, one in the United States that we're working with, and another fertilizer company. We have a fairly solid team, and we have over 105K acres in pipeline, lots of operational time, a lot of support. Things are getting very interesting. So here's our team. Those of you, some of you will remember me from Selectron. And so we have been a battered and bruised team with several decades of experience in building and shipping hardcore hardware. Our team includes also Prakash Iyer, who's the Senior Vice President at Triple Navigation, Jignesh Patel, who's like one of the figures in big data. He sold his last company to Pivotal, the one before that to Twitter, and Wen Mei Hu, who is one of the leading researchers in large-scale computing in the United States. Also, as part of the team, you know, when you look at a team, you've got to have science, engineering, and operations. On the science side, we have 3 really strong individuals. Lloyd Knightley, who's a PhD out of UW in plant physiology. Carissa Liu, who's a PhD out of Stanford in magnetics and sensing. And Ted, who's on the right-hand side there, who's a PhD out of National Taiwan in computer science. I head up engineering. Anwar is ex-Walmart BI. Kevin has been working with me for about 20 years. So this is our roadmap. Today we focus on moisture, having a wide radius, and also above ground sensing. And our focus in the market is irrigated farmland. In 2017, we'll be adding aggregate salinity, which is, for those of you again who are on the farm, you know what in practice what that means, plus aerial imaging overlays. In 2019, we are moving our sensing to the ability to pick up and detect individual salts, which are nitrates, phosphates, and other kind of things like that, which will allow us to expand to non-irrigated land, which is several times bigger globally. We do have a fair amount of competition. The one that's getting a lot of press right now is the right-hand side, is PropX, and they're out of Israel. They've got 18 million in funding. This is a very hot area. We believe we have very strong competence across science, engineering, operations, and we own the stack. I'd love you to take a look at where we are, and if there's an interest in working with us in either capacity, we love customers, no experience required. We love investors, some experience requested. And we love the opportunity to also talk to potential new team members. Thank you very much for your time, and open for questions.